we can write the intercept form of the quadratic function if we are given a random point x comma y and the x-intercepts p and q. Our steps are similar to our other examples. So we're going to substitute the point xy and the x-intercepts p and q into our intercept form of the equation. We will then only have a as an unknown, and we can solve for a. We'll then substitute the x-intercepts p and q along with a back into the intercept form to write our final equation. So let's take a look at what this will be. In this example, we want to write the equation in intercept form. I can see that I have a point right here. It happens to be the vertex, but it doesn't have to be. So my random point on the graph is 1, 5, giving me an x value of 1 and a y value of 5. My x-intercepts are here and here. So the x value of the first one is -2. So p is -2, q is 4. I'm going to substitute into this equation. First with my y value, which is 5, and that's going to be equal to a times x, but I know x is 1 for that point, minus p, but p is a -2, so that's going to become a +2. And then x again, and minus q, which is 4. So just substituting everything I know, and now I will solve for the one thing that I don't know, which is a. 5 is equal to a times 3 times -3. For my next step, I can multiply 3 times -3 and get -9 times a, remembering that we always write the coefficients before the variable. And then finally, I'm going to divide both sides by -9, leaving me with a is equal to -5/9. Now I can substitute that back into my original intercept form of my equation. To remind you, it's y is equal to a times x minus p and x minus q. But now I know a, p, and q, and I can plug those in. Y is equal to -5/9, x minus p, but p is -2, so that becomes a +2, and x minus my q value of 4. So this is my final solution. Just like before, in the next problem, we're given the intercepts and a point that it passes through. I'd like for you to pause the video and try this one on your own. Come back to see how. All right, so you should have identified your random point as 1, 84, and the p values and q values as -5 and 8. Plugging into our equation with y of 84, x of 1 in two places. P is -5, but the equation has a negative in it, so that becomes a +5, and q was an 8 with the negative from the equation. Simplifying, we get 84 is equal to a times 6 times -7, and finally multiplying and dividing, we get an a value of -2. Substituting into our original intercept form of our equation with our a value of -2, p value of -5, which becomes positive because of the negative that's built into the equation, and then our q value of 8, again with a negative because of the negative in the equation.